Oh my gosh, congrats.
Last week we got.
I don't think
I'm so proud of you.
Mm.
We got cookies last week.
Oh, do we have to click this? Thank you.
I don't know what we got.
Yeah.
Where did it go?
Go to the other workspace.
See the next to the end screen button on the right.
So where did I?
Oh.
17. I'm sorry.
No, I think we're good.
I couldn't understand that confusion there. That's weird.
You don't really need anything.
Actually, I'm gonna leave it here so that we can show this.
Do you have a CTF?
Oh, not yet. I think we'll set those up like after, like I think like 1700-ish. We'll do that.
Yeah.
John, goodbye. Goodbye.
I just have my old computer. It takes a bit. All right, Michael. The downloading counter when I ship them up.
Which books are you covering today? Huh? What are you covering today?
Dynamic reversing. So it's like that's more like just like looking at stuff in GDB and running it and like figuring out like what's going on. But like just giving a binary. I don't like BitX. It's like between reversing and BitX. Okay. I guess the big difference between like reversing and BitX is like reversing is just like figuring out what it's doing. Yeah. Then just doing like what it's supposed to versus BitX is like an exploitation. So it's like not supposed to be happening, you know?
Yeah. Are you doing like cracking stuff?
Cracking?
Yeah.
I actually just made 2 problems.
Good.
You need to say that definition of reversing.
Oh yeah.
I know. Just like
Yeah, I think once everybody gets it. Does anybody have any questions about downloading the files? Is everybody getting good points?
Get them all. Get them all. All the files. All of them. Every one of them. Put them in your own directory. Put them in a reversing, dynamic reversing, super wonder.
Really, guys? Really with this one?
Hello.
Oh, dude, I got it.
You broke it.
Good job, Lance. Good job,
Hey.
guys. Enough.
So do we download Hello?
Yep. And then those links there. So in this links folder, we have a few useful tools. And if you don't have any of these, you can go ahead and use them. Ghidra is useful. I don't know. I don't think we're going to use that today. We might. Yeah, so
You
you're
probably
good.
have Ghidra. Maybe. I don't know. Maybe.
Pwnabug, I'll show this later on. And then this is just a little cheat sheet for x86 instructions. So. Yeah, so they're 2 different like plugins for GDB that we'll talk about.
I used Jeff for a long time. I just started using Pwnabug. It's like a pretty good transition, honestly.
Yeah. All right, who's still working on downloading the files?
Yeah, you'd have to have
Nobody? Okay. I need to download the file.
You're still working on it. Can you, whatever, just do it.
What? Boop. Let's go, yeah, let's go make it a zip. Awkward. Okay. Should I do them downloads?
So Jack, what files are downloading again?
Everything, just don't download the links document. Everything except for that.
Yeah.
Mm-hmm.
Unzip. Why is that on here?
Are you in my account? Wait, no, why is that on the
I don't think I put this in the right place.
Just run it real quick. Run them.
Okay.
It's a non-functional version of the antigen. Okay. Yeah, that's splitter.
What does that do?
Nothing.
Okay, so we're gonna get started. So I think the first one we're gonna work with here. Oh, and just like for like clarification, like what is reversing versus like binary exploitation? Like with reversing, you're looking at like a binary and like the assembly instructions there, and you're not trying to like exploit it. You're just trying to figure out what it does so that you can like work with it and like get a desired outcome. But binary exploitation, you're looking at the assembly and you're looking at a binary and you're trying to exploit it, like as it says in the name. So like you're trying to do something that the program is not meant to do. So we're looking at things that the programs are meant to do and then trying to just make it work. So first thing I want to run over is just kind of a look at GDB again. So I made, and I sent y'all the source code for this too, this hello.c. And so it's just a hello world. Might be a little small there. But we're just going to run through that really quick in GDB. So we'll run GDB and hello. And it looks like we already have Jeff on here, so that's cool. And so I linked Jeff in this links here. And if you're wondering how to install any of these, they have instructions just right at the beginning or somewhere in the GitLab or the GitHub. So
If you have problems with that, just call me over.
okay, so we've got ./hello here, and so we're looking at it. We've got, doesn't look like we have any problems. This is no debugging symbols, but we have symbols here, so it looks like we'll have breakpoints. So we can go ahead and look at main, and pretty simple there, huh? So got push RBP and then move RBP RSP, and then the stuff at the top. This is all just setting up the stack frame. So any questions about that so far? Cool. And then we got this call to puts, which interesting enough, I mean, we set a printf in the source code, but compiler changes it to puts because it just does that. It's like that's easier than doing a printf, so that's cool. And then move this return into our EAX, and then we leave. So this is just that return 0 at the end of the program. So super simple. So let's go ahead and look at this dynamically. So we'll do. Uh-oh.
You gotta schmod it.
chmod, yeah, that's true.
So always make sure you can run your files.
Or else you'll be a little stinky like me.
Probably did that like 100 times. Just wouldn't be able to run our files and try and debug them.
Cool. So it just ran in and we just saw it run. Awesome. But we kind of want to see like what's going on. So I'm going to set a breakpoint at main. And so that B, you can shorten pretty much everything in GDB. Like you, instead of saying like info registers, you can say IR. If you say info frame, you can do IF. So R stands for run. And so then it brings us into main. It actually kind of skips forward a little bit. Like main plus 0 is right here. And we're all the way at main plus 4. So here in Jeff 2, just to like point out a few things. So it actually gives you a lot of information you don't have in main GDB. So up here, we have all the registers, and it gives us these like nice color codings. So it tells us which ones are modified. It tells us what's code, what's on the heap, what's in the stack, and what are strings. So nice information there to see what are in the registers rather than having to run info registers and look at them individually. It just gives us them. And then also we have the stack here. So it's showing us all the stuff that's on the stack. And then this is our current instruction. And I don't know what I just did. and then this is the stack and current instruction. And this is what the instruction pointer is looking at. So if we did,
Control that.
yeah, let's just do that. So if we looked at our RIP, it's right there. And then we can do x/I, or we can do x/10i. So examine instruction is what that means. We can look at RIP, and it's the same thing. It's just showing like where we are in the program. We could even do like -5 there, and then it'll show us like this is the beginning. Here's main. So pretty useful. So we are at main plus 4, and we kind of want to see like, well, we're calling puts, but like where's like the hello world string? Like how is that like getting printed out to the screen? So it has to be like loaded somewhere, right? So does anybody like have an idea of like where that string is? Yeah, it's kind of hidden, isn't it? So calling conventions in x86 are you use this RDI register, and we'll go over this, I guess, at another point, but there's certain like registers that you can put arguments into, and then when you do a call, it'll look like the function that you're calling will look inside those registers for arguments and then operate on those arguments. So we see here that we're loading the effective address of something that is at RIP plus an offset. And luckily enough too, in our debugging like labels here, this is actually that address. So RIP plus 0xEC0 is this address right here. And so we can actually look at that. I think if we do x/x, then I'm going to see if this works. So yeah, there's our string right there. And so that's the address of the string. And so
sorry.
You can go ahead.
The important takeaway, one of the important takeaways here is like you're not going to be able to just look in the disassembly or look in like your like instructions that you're running and be able to find every bit of information that you need. You're going to have to dig a little bit through GDB, especially once we get into more like involved reversing problems to find strings or integer values, for example.
Yeah, so even like in this hello world, like hello world wasn't just like puts hello world. We had to kind of look to see where it is in this address here. And so then it's putting in RIX, and then it moves RIX into RDI. RDI is like the first argument for like the function that you're calling, and then it calls puts, and then we exit. So we continue here. So continue, you can run it by typing out the full thing, or you can just do C, then it prints that out. A few other things. So if we go ahead and run again. So with next instruction, this is something that I didn't like really know until like some point later on when I was working with GDB. If you run next instruction, so we'll just run this a few times, we get to the call here, and then if I do another next instruction, we just go right on to the next instruction. But if we rerun this program, if I do next instruction up until this call, and then I do step instruction or step into, then I am now in like the puts function call. So this is a bunch of like really complicated stuff that honestly I don't really understand what's going on. But down here you can see like the main stack frame is down there, and then this is like our function stack frame. And there's just a bunch of crazy stuff going on. And if I keep doing next instructions, like it's just going to do all this library call stuff, and then finally it'll do the call. So
yeah, usually you never need to step into a library function. If you're stepping into printf, you're just going to waste your time. The only time you want to step into a function call is if it's a user written function, like a mystery function or deobfuscate or whatever, some type of other thing.
So you want, if you start to see like puts or printf or gets or something like that right in here, and it might be a little bit different in base GDB or in Pwn debug, you want to make sure that your offset or like your address of where you are is within the main method, the main function, or whatever function you're currently trying to be in. And it's a quick check on yourself to be like, oh crap, I'm actually in puts right now. That's why my values are all weird. Just a little bit of a sanity check you can do to yourself is to look there.
If you do get stuck inside of it, you can run the finish command, and that'll take you all the way out of the function you're currently inside of.
Yeah, so useful stuff there, because I had plenty of times where I was doing step and twos, and I was just like, man, this is impossible. Like I've got to press enter so many times just to like get through this program, and I would go like rabbit hole down into function calls. But you just want to do a next instruction, so you jump over it. So
as you're going through it, instead of next or step, you just typed it once and pressed enter. You just kept going. Does that happen with everything, or just?
Yes. So when you run like an instruction, then if you press enter again, it just like repeats the previous like a command that you put in. So that's like a GDB thing, and that's also the same for Jeff or Pwn debug. So yeah, good point there. Good question. Yeah, so like let's say, well, I guess there's no example of it in here, but if there was a loop and you set breakpoints like inside that loop, then if you run like continue, it'll keep breaking at that same breakpoint, and you can just keep pressing continue, and it'll just keep going there. So like if you're in a while loop that has like some sort of counter, then you can keep breaking like in that while loop and check the counter to see what the value is. So makes it easy if you're dynamically reversing to just kind of press enter a ton of times and see what's happening. All right, cool. So anybody have any questions about this hello world reversing, or like anything they want to see like in this hello world? Anything that didn't make sense? All right, cool. So pretty simple, not really much going on there besides just printing a string to the screen. So the next thing I want to look at is we have this reverse one binary. And so let's just look at, usually you want to run like file on it just to see what it is, but I think y'all learned that last week, right? So 64-bit binary, it's not stripped, but we don't know what it's doing, right? So what do you think the first thing we should do with our binary that we don't know what's going on with it? What should we do with it first? Yeah, just run in and see what's going on. Oh, and I got to chmod it first too. The classic chmod. All right, so enter a number. All right, what number should I enter?
100.
100? 45? 25. Okay. So your number is now 122. Okay. Let's do 100. So 156. 3, 82, 0, 84. All right. So my idea for this one is let's figure out what's happening here. Like, what is it doing with our like input number to get our output number here? So like anybody off the bat just want to like guess what's happening? It's increasing it. Let's see.
A negative number.
A negative number. Let's do -10.
Is it increasing?
Yeah, is it increasing it every time?
Let's graph it.
Yeah, let's graph it. So a little tricky, huh? We don't really know like what's happening between the input and the output, but we could probably figure it out, right? So another cool trick you can do before you even open up something in GDB is you can do objdump. No, I'm just kidding. Objdump, and you can do tag D, tag mintel, and then we will do reverse one. And so this will show you a bunch of useful information. Don't really need to worry about any of these other sections. Really what I want to look at is main. So you can do this in GDB, but if you just kind of want to not enter GDB and like look at this, you can just open it up in objdump. So looking at it really quick, what is this stuff here at the top right here happening? Yeah, I'm making the stack. Cool. And then we're doing something here. What does this kind of look like? What was that? Yep. So we are taking something from an address and putting it into RAX, and then move it into RDI, and then move something into EAX, and then what's going on here? Yeah. So if we see all this going on here, what do we think's happening there? Yeah. So it's just like the question at the beginning, like enter a number. Cool. And then we're loading the address of something else and doing another call down here. So what does this look like? The opposite of printing.
Taking it and scanning it in.
Yeah, scanning it in. And then we break it up into one more block. What do we see happening?
At the end of it.
Yeah. So we just broken it up into the 3 blocks that are happening there. So we've got our printf, our scanf, and our printf. And it's really nice that all those little labels are just kind of added in for us. So not even doing any hard work, not even having really to look at these instructions yet, we were able to kind of see generally what's happening here. So if we're looking to see like what's happening to our input, where should we be looking at in here to kind of gauge what's going on? Yeah, this like 3rd block after the scanf, right? Cool. So let's see what's happening. So just kind of like looking at what's going on here, like if you see stuff that's happening with RBP, that is usually going to be local variables. So like in C, when you say like int x equals 0, it's going to define that as a local variable on the stack. And so when we see RBP like minus 0x8 or RBP minus 0x4, those are local variables that are on the stack. So it looks like what's happening here is we're taking some variable off the stack, we move it into EAX, and then what's this right here? Yeah, so we're taking whatever was on the stack and we're XORing it, right, with 0x2a. Yeah, 42, nice. And then what's this right here? Doubling it? Oh, so just this instruction, like if you take something and you add it to itself, yeah, it's doubling it. And then it looks like we just take the result of that, put it into another local variable, and then after that, we put that back into EAX. So that's usually like a reassignment. And then this is kind of like the setup of doing another printf. So it looks like pretty much all of our stuff that we're doing with our local variable is pretty much just happening on these two lines. So XOR it and then add or multiply it times 2. So let's do a sanity check on that one. So Jack, what do you have on the board over there? 42. So we want to run this with 42. Ooh. Okay, so Jack, you want to go ahead and explain what's happening?
Yep. Okay, so this is our input, right? Our input number is 42 here. What did we say was the first thing to happen? What do we XOR with? 42. Okay. So, convenient example here. XORing, what happens when you XOR a number with itself? Right? Can anyone explain to me why that is? Little XOR lesson.
It's like Boolean, like logic. So if it'll be true if it's the two things are not equal to each other, or false if they are.
Yeah. So XOR is bitwise, right? So we go bit by bit here. We're doing a bitwise XOR. So this first one, 0 or 0, exclusive OR. Okay, still 0, 1 or 1 XOR. If they're the same, then it's 0 because it has to be only one of the values. So we're still with the 0 here, and we can just continue that on. And so our result of the first check of the XOR is 0. And then what's the next thing we do?
Add it to itself.
Add it to itself. Okay.
God, this one's hard.
Yeah, this was a really tough example.
Yeah.
Whoa.
Cool. And let's do one more sanity check so we can see that there's the multiplication of 2. So what number do we want to try this time? 43. 10. Cool. So it gets a 64.
What's 10 in binary? Yep.
Whip that out.
That's quick. Okay, and then 42 is.
Whoa.
Yeah. Okay. So what's the XOR here? Yeah, we're still with zeros, and then you pad out zeros.
0.
So why is the last one there still come out?
They're not matching, right? Like 1 is 0, 1 is 1.
Yep. So exclusive OR. One of them is a 1, then you carry it.
XOR only pops true if like only one of them is 1. So that's useful. And then we add 1, 0, 0, 0, 0. Okay, and we get 64, which is just one more 1 in the end, right? Because it's like just like base 10, you just get an extra carry over here, bring it down. And that's our 64. All right, we got 1 plus 2, 4, 8, 15, 32, 64.
Nice. All right, now let's look at it in GDB because we've done our sanity check. We actually know what's happening, but let's just even further make sure we know what is going on. So we're in, and then gonna look at main here. A harder input. What's the hardest number anybody knows in here?
It's like a really hard number, like a number that you can't.
Yeah, it just hurts your brain. Like if you're thinking about this number, like hurts to think about.
It's like a really hard one.
7. Oh, dude, all right. Chill, dude. 31. Okay, 7 and 31 are 1031. That is pretty hard. That's like 1024 plus 7.
Yeah. We'll do 31.
31, yeah.
What is it? 16 plus 8.
Yeah, and then I will set a breakpoint here. I kind of want to do it like before these operations so we can see what's happening. So I'm going to do it right after the call to scanf. So I can do star, and then I can do main plus, and then we're at 55 here. So this little notation down here is like if I didn't want to enter in this massive address to set a breakpoint at it, I can just use the debugging symbols with a star in front of it, which means pointer. And then I can say plus 55, which is the offset that it's at from that label. So by doing this, you'll see it sets it at 1180, which is exactly this one, which is main plus 55. So kind of useful for if you're working in GDB and you don't feel like copying massive things like this. Yeah, copy and paste isn't very hard, but sometimes it can be nice to just not have to think around and copy and paste stuff. So if we run this now, it's going to ask for our number. We're going to give it 31. All right, so we're at move into EAX, and then the D-word pointer RVP minus 0x8. So we haven't run it yet, so it hasn't moved anything into EAX, but there is something at RVP minus 0x8. So if we look at that, so we can look at money RVP minus 0x8, then we have this number right here. So 1F is at that address. So 1F, that's 1, and then followed by 1111. So the number on the board there. Awesome. So it's got our 31 on the stack, and we're moving it into EAX. Cool. So if I do next instruction, and then if I did info register money EAX, what am I going to see in EAX? 64?
Well, look where we are. Look what's about to be run.
Yeah, so we just ran to move it into EAX, what we were looking at that was on the stack. So if we look here, it just took that thing from the stack and put it into EAX. Awesome. So now what's going to happen based on where our instruction pointer is? Yep. Exactly. So we're going to XOR what is in EAX with 2A or 42, and then that result is going to go into EAX. So if I do next instruction, and then we look in EAX, we have hex 35. So let's see. Jack will do it over here by hand.
This is 32 plus 16, 48 plus 4, 42, 43.
43.
53.
53, and that makes sense because this is 48 plus 5. So 0x35 is the same as 53. Cool. And then it's going to just do this next instruction. So what's happening here again? Yeah. It's doubling, yeah. So if you're adding something to itself, that's just multiplying times 2. So we do next instruction. We look inside again. Now we have 6A. So 6A, 16 times 6, that's 72, and then 82. Cool. So let's see what we finally get here. Oh, sorry, yeah, 106. Is that what we got over there?
Better be.
Cool. I'll hit the believe button on that one.
I believe.
All right, sweet. So I think we've covered that one pretty in depth. So if anybody's any questions, ask them now. Anybody got anything? Nothing? All right, cool. So I've made this reverse 2 right here, and I want to give it to y'all as a challenge. So if we run reverse 2, it's asking for a password, and you can enter in something. So you can do like Jack, and then it'll say you lose if you enter in the wrong one, or it'll say you win if you enter in the right password. So my challenge for y'all is to figure out what is the password you enter so that it'll say you win. So I'm going to unleash y'all on that one, and we'll walk around. And if you have any questions, feel free to ask.
That was a firehouse.
Yeah.
So
Yeah,
let's just.
I'm actually going
I mean, I don't understand the
quick.
problem.
Yeah, that's a start. That's a start.
But I just kind of know what to do for yourself on the phone and
Yeah.
that's awesome.
Yeah.
Hey, John, can you see if the harsh is in
So,
there and get his tally
This
stick?
is like the source code of a program right here. Like, it's just how it works. So it's similar to what you see in Java. Just including libraries. This is like,
I got this.
you have your main function, which is called printf. So pretty standard.
Are you?
So this is like all this gibberish. It's like a debugger. So like if you want to step through a C program, you can use a debugger. Or like really any kind of program, you can use a debugger.
There's a folder that had this.
Okay, so executing stuff like that. So it's a tool that we use a lot. So in this case here, what you're seeing is like it's showing the source code of the program. So here's the source code. And then this right here is the actual assembly instructions that are executed on the hardware. There's a big, beautiful diagram that I drew there. So like all of these instructions are in the computer, if that makes sense. And then they just tell line by line, like do a very specific thing. Honestly, I don't know what all of the colors mean, but usually it's like red means something just changed.
But they do.
Well, yes, like gray is like stuff that's already happened. This is like what the current instruction is, like that's about to happen. And then this is like
It's moving it in there right now.
so like these two instructions, like these two lines up here. So like main 0 and these two things that
Does
push.
this like correspond to
Yeah. Yeah, because basically when you compile code, it's like the compiler takes in source code, interprets it, and like spits out the assembly instructions for specific types of architecture. So like this function here that says like print out hello world, the assembly instructions for that is it's calling puts, which is another printing. Since it's only printing out a string and doesn't have any like special bells and whistles to it, it can just substitute this puts function call. So all that's going on here is it loads in like hello world, the string has to be saved somewhere in the program. So it just loads that address up into a public register, which is like a part of the variable information.
Especially because it loads that string, no matter how you do it.
And then this is like the move EAX 0. This is like the return 0. So like the EAX is a register, which is like there's 32 process. And EAX is the one that's for like transfer values from that function. So like
What do you see so far?
if you were doing Java code and you had return like
Oh yeah, you're good.
value like return X or the equivalent value is like whatever your final thing is.
You just tell me. I mean, you don't.
So it gets put into EAX. Like assembly instruction. Does that
Makes sense.
that make sense?
It does.
So we can see here as like right now the program has like these two things are just every time a function gets called in assembly, like it sets up kind of a workspace inside.
You got a really good start there.
And then at the end, it tears that workspace down.
Are we trying to get like the actual password?
Releases it back again.
There's an actual password.
So that's where these two things are going to expire. They're not horribly critical when getting the gist of stuff. So like the first thing we're going to see here is like, right now, RIX. This, like, here's all of our registers. Right now, there's nothing interesting in RIX, but after we go forward to one instruction, so yeah, so like, I guess I can't do that.
But that is what it means.
Yeah, so after doing NI, you can see that RAX now holds this value, which is an address, like a pointer as it's called. It's an address to somewhere in memory, is how it works. So it's the same way as in Java, you have a variable. So technically, everything's a reference. Like, the pointer is in reference, like in Java. So the RAX register now has this value, which is in reference to the string which is written in. And then the next thing that happens is this move instruction here. So the syntax is like destination source. So like
When you press it again.
Probably looking at uninstall. Like, I know there's like a directory where probably is installed and you can.
so this is right down here is saying like this is the function you're currently within. So like right now we're still inside the main function. Yeah. So like we're still inside the scope of the main function. If I were to do like step instruction, I'd then be inside of the puts. So we keep showing like main and then like puts would be right. But like we can see here that now the RDI, so this other register called RDI now also has a pointer to hello and like has that address. And the reason that is there's a ordering for like when you want to call a function in assembly, you put the arguments to the function. Like a specific order. It's like RDI, RSI, blah, 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 blah. Like just Google search whenever you need to like remember that stuff.
It's not just like.
And then, so like here, if I were to do like step instructions, so like take the very next step, now you see that we're inside of the puts function.
That's different from the next instruction.
Yeah, so next instruction says like, next instruction won't go inside of function calls. So like I'm in main and I'm about to call like printf puts. Next instruction it'll execute the printf function call and go to the next thing. Just, we can sit here forever. Yeah, like. And so like, and like all of this garbage here, where it's like DL runtime resolve, is because a whole lot of spiciness about how, like when you first load up your program, it doesn't actually know where these library functions exist. So there's like a function that helps it find these other functions so that it can call that function.
And so that's what you do.
Well, this is like still like trying to figure out where. Yeah, so like first it has to call a function to be like, where is puts before it can actually call puts. But we're not there. Just get this stuff that helps. Okay, cool. So now we're back at it. So we're now back to we're back here.
Yeah.
So this is the return 0, and you can see now that it's highlighted down here as well. And then the comma like final return values like saying now main's over with, so now we're back into like the operating system. Okay, cool.
It makes sense. I don't know any basis before from my code, but
Yeah, so really like we're just trying to show like here's the source code in C, which looks similar now that it's kind of familiar, and then it's like here's the assembly instructions that are less familiar, but they're not as crazy as they each do one like specific thing. It's just not as easy to look at it like high level. Like what is this? It's, individually they don't mean a ton. It's like, together is when they start to feel something. So like questions.
About this specifically?
Yeah.
I mean, I don't really know. Yeah. I mean, it's cool. And I want to try, but I mean, it's also a lot of stress. I don't know. It's I mean, yours.
You gotta start something. I literally like sat in this room, or like got this room over in Leahy Hall, which is a condemned building. Being like, what's going on? It's like a whole year. So, it seems like a lot. It's just sometimes a lot. Yeah, but it's nothing crazy. It's doable.
I mean, I'm very good at this. Someone tells me what to do. I'll do it.
Yeah, so
You're wrong for right now. Obviously, eventually, every user. But what is that comparison doing?
This is the first one I went on. And then the
yeah.
second one was the one
In
that
reference, like, what's going on in the program?
Oh, so this is the reverse one. So this is that XORing stuff that we're talking about.
Yeah, that's exactly. So do you think over here, it doesn't do anything.
So they didn't give us the source code roughly.
So like now, it's fine for.
They didn't compile the source code. So you can't see why. Here's what this does. Looking
What were they doing before?
yeah. Yeah, well, so that was, so you can get the disassembly, or in this case, the assembly instructions of the main function. It's like we don't have the original C code of like print out or like scan out, like get input.
I think at 17, I'll give it.
Yeah, we can look at these assembly instructions to try to get a gist of what's going on here. So like, we know this stuff is just like setting up like the beginning of the function. So that's all. You're always going to see that. Like these two lines actually. So this part right here, we see like it's loading some address and then calling print app. So that's probably, yeah, great, awesome. And then after that, we see that it loads some more addresses. And then it calls scan app, which is a twin of get VA. Yeah, so it's getting this is getting the input from the user. So then after that, like these functions are where stuff gets like these instructions are where stuff gets. Yeah. So like down here we can see like this looks like another standard like printing out the answer, right? So like, yeah, this is where like this load address through print down here is like printing out this, like you're right or wrong, or like they're like here's your final number. Yeah, this is just like here's this is your number. It's really like we know that.
And then the next one is $sign.
This scanf function here like reads in like the user's provided number, and it places it into memory at like an address, which is what this ODD pointer of everything is. We see that the next instructions are like put that in this EAX register. We see that EAX gets XORed.
Oh my gosh.
XORed, so it's exclusive OR.
I don't know how to prove it.
Yeah, the magic zero is one. So usually that's like up here.
RBP minus 80 through RBP minus
programming or something like that.
Using X plus add.
And then we see that they do add EAX. So that's like added to itself. For like X plus equals X. And 2A is 42. So it's basically like X
There we go.
equals,
That's one
or X equals X
Yeah, I think X is in
up caret 42. and the next line X equals X, and then it's X.
I'm just gonna go.
You're just gonna do a hand by hand.
So we set a breakpoint, which is like run the program until a certain like assembly instruction that stops and like inspect stuff. And then we can like walk through it. So we'll just break it in main.
What's up?
Oh, we already have a breakpoint. You'll see like this address, it's gonna set it.
Yeah, it's like a variable.
Yeah, I forgot it. So.
Oh, trust.
We're gonna be.
Did I miss that?
So, okay.
Yeah,
Anyways, we'll run it, and you'll see it stops us right at like this sub instruction, which is still part of the like, function setup. Yeah, it's basically like in memory. Like each function gets its own scratch pad, so it does a couple things to like set up that scratch pad. Where X, like you say, like it's X equals whatever, like that has to exist somewhere. It's perfectly not inside the register. So that's like in memory, like these instructions are setting up that scratch pad. So X after the function has to kill X, and that's why like function start is so we know that this stuff is just like, tell me your number. And this is like, give me your number. So we'll just set like a breakpoint for this line right here.
And that, like,
Yeah, like it'll, like, after this we can say continue running the program, and then it'll stop again. The last breakpoint we say, so we can say like, let us type in the number and all that stuff, and then stop again once you hit that line. So that's it. So now if we just continue, enter a number. So we say that same, just keep reading. So like breakpoints call like those do instructions. It continues like 30 instructions until like say hold like until so if we enter the number 42, like so that like the printf was like enter the number, the scanf that it was waiting on was like press type in 42. Yeah, and then when we hit enter, now it's like okay, here you go. We're giving you back.
What's the flag? I'm just brute forcing.
So we can see
How long is the flag? I'm brute forcing.
Yeah, X here is about to change. Right now it's 1 because scanf returns like here's how many things I successfully read. So we did read in one number, it's like half. So the next instruction is going to change to 2x and X, which is 42 in decimal, which is what we had. So we're just going to XOR EAX with 0x2. So anything XOR to X itself is going to be.
I'm gonna give everybody like 2 more minutes, and then we'll bring it back like over here, but keep grinding for a little bit.
So we're going to run this next instruction here. We see now it's 0. We now add EAX. EAX is 0.
When you got the password wrong.
Yeah, well,
Number is not.
So what does it compare to?
Yeah.
it takes your input.
I mean,
here's it with
yeah.
what the right thing is, and then
It's not
when you
black
combine
magic.
it, and it's
Like you can see the.
Yeah.
So the compare, all the compare function does is it looks at the 2 bytes, looks at the 2 things.
So now reversing is 2.
That's a bunch of flags.
Yeah. Reverse
So after
2.
I compared like 1
Oh,
and
actually,
15,
let's look at
let's say I had the integers 1 and 15.
What's it do? It's like enter a
I
password.
compare the 2. Well, what happens is a bunch of flags would be set. There's like a 0 flag. If the result of those 2 comparisons is 0, they're like they're equal, then that flag will be set to 1. Or if 1 is like 1 is less than 15, then the less than flag
So I
will be
just
set to
set a
1.
breakpoint.
If it's like greater than or equal to, then that flag will be set to 1.
So
after that,
yeah, so we're in the middle of the program right now. But here's like the whole functions of the assembly. So what is these green 3 things? Yeah, setting up the strings. We see a whole bunch of weird looking stuff. Right.
So
These look
registers
suspicious.
EDX and
They'll probably
EAX
come
are
back to that.
equivalent, then you'll jump to that location. Okay, so now trace the program, follow the program at that. So JNE is jump if not equal, and JNE.
Yeah, so we see this.
You're looking stuff that we'll come back to.
Yeah. I mean, but Yeah, honestly, anytime you're like, this looks sketchy, it's probably.
All right, everybody, we're gonna start reeling it back into the middle here now, and we're gonna start going over just like a little, like few hints for this, so that we can figure it out. So I've got the dump of this binary right here, and looking at the top here, we've got the we're creating the frame. And then I'm going to be honest, this kind of thing right here is super suspicious because we're pushing a bunch of values onto the stack or moving them onto the stack. So this right here, put it like a red flag on it, like something is being put on the stack. Now if we keep looking, if we move down here, so we can see that we're doing a call to printf here. So we can probably guess that this is like the what's the password, and then we have down here we have a scanf. So this is kind of like the grab the input portion right here, and then this down here. So right after, yeah, right here we have a jump, and we're going down to 0xe8 of name. So 1241, that is right here. So then we're doing a comparison of a local variable to f. And then we do another jump. So kind of if you look at the jumps here, you'll see it's doing like a loop. And so it keeps kind of going up and then down and then up and then down. So kind of like a loop, either a while loop or a for loop. We don't really know what it is. But the important thing to see if you kind of graph that out is that, so you'll be moving down here and you'll be doing some operations. Then right here, you see this kind of like XOR and compare, and then you jump back up in the code. So you go back to, or I guess you just jump right down here. Or am I looking at that wrong? 1, 2, 3, D, somewhere around here. Yeah, so it jumps and it does this addition, and then it compares, and then it jumps back up to somewhere up here. So key point is you can look at these two things in GDB and see what is being compared. So that's one of my hints. The other hint is this bad boy. We had one person figured it out. It was Ron. So also, if you have questions, Ron can help you out there. But I'll continue to allow y'all to grind on this one. But that's all we've got today for reversing. So come back tomorrow hungry for more reversing.
Not allowed to leave until you got it.
You can leave before then. All right. Thanks, everybody.